Welcome, and thank you for being here, in whatever quiet corner of the world you have found tonight. Maybe the lights are low, and the room around you has settled into that comfortable hush that comes only in the late hours. Maybe you are lying somewhere soft, and the ceiling above you is the last thing your eyes will rest on before sleep finally arrives. Wherever you are, I want you to do something simple before we begin. I want you to hold very still. Feel the weight of your body, sinking into wherever you are resting. Feel the stillness of the air around you. And now, I want to tell you something that might gently, quietly, change the way you experience that stillness forever. You are not still. You have never been still, not for a single second of your life. The chair beneath you, the bed holding you, the floor of the building you are in, all of it is moving. The Earth is spinning on its axis at roughly 1,600 kilometers per hour at the equator. At the same time, it is racing around the sun at nearly 107,000 kilometers per hour. And the sun itself is not sitting peacefully in place. It is orbiting the center of the Milky Way, carrying us with it, at around 828,000 kilometers per hour. These numbers are already enough to make the mind go quiet. But we are only just beginning, because the Milky Way itself, our galaxy, this enormous island of 400 billion stars, is moving too. It is not drifting gently. It is not wandering at random. It is being carried, along with dozens of other galaxies, along with the entire local group of which we are a part, in a single coherent direction, at a speed that dwarfs everything we have already mentioned. We are moving through the universe at roughly 630 kilometers per second. That is more than 2 million kilometers per hour. That is a speed so vast that if you could travel at that pace, you could circle the Earth at the equator more than 50 times in a single second. And we have been moving like this for billions of years. For most of human history, we did not know this. We looked up at the stars and thought they were fixed, embedded in a great dome, permanent and unchanging. Then we learned the Earth moves. Then we learned the sun moves. Each discovery was a kind of falling, a realization that the ground beneath our certainty was not solid after all. But the discovery we are going to explore tonight may be the strangest falling of all. Because for decades, scientists asked a simple question: why are we moving in this particular direction? What is pulling us? And for a long time, they had an answer, a dramatic and mysterious answer called the Great Attractor, a region of immense gravitational power, drawing our galaxy and hundreds of others toward it, like a river being pulled toward a vast and invisible waterfall. But that answer, it turned out, was only half the picture. We were not just being pulled, we were also being pushed. And what was pushing us was not a thing. It was not a massive cluster of galaxies, not a concentration of dark matter, not a single enormous object. What was pushing us was something far stranger, far more unsettling, and in some ways, far more difficult to understand. What was pushing us was nothing, a vast, almost incomprehensible nothingness, a region of space so empty, so devoid of matter, that its very absence creates a kind of pressure, an anti-force, a cosmic wind at our backs, not blowing from something, but blowing away from nothing. This is the story of the Dipole Repeller. And before we go any further, settle in a little more deeply. Let your shoulders drop. Let your breathing slow. Because what we are about to explore is not a threat. It is not a danger. The Dipole Repeller has been pushing our galaxy for billions of years, and it will continue pushing long after every human being who has ever lived has become part of the stardust it moves through. You are safe. You are warm. You are resting. And you are moving at 2 million kilometers per hour through one of the strangest cosmic stories ever told. If this kind of slow, wandering journey through the universe is the kind of thing you want more of, a like or a subscription helps this quiet corner of the internet reach others who might need it. The cosmos is large enough for everyone to find a little wonder before drifting off. So let us begin at the beginning. Not the beginning of the universe, but the beginning of our understanding. The moment we first realized that the Milky Way was not sitting still. There is a particular kind of vertigo that comes not from heights, but from knowledge. The vertigo that comes from suddenly understanding something you did not understand before, and realizing that the world you thought you were in is not quite the world you were actually in. Children feel it when they discover that their parents are not omniscient. Adults feel it when they discover that the stories they told themselves about their lives were only one version of events. And scientists feel it, sometimes, when a measurement comes back with a result that does not fit the world as they understood it. The discovery we are about to explore produced exactly that vertigo, not in a single moment of revelation, but gradually, as data accumulated and models were refined, and the picture slowly came clear. A picture of our galaxy, moving not at random, not aimlessly, not in response to some nearby local influence, but in a sustained and directed flow, shaped by forces operating on scales that dwarf anything we had previously considered. And at the heart of that picture, stranger than any attractor, stranger than any cluster or supercluster or filament of the cosmic web, was an absence, a nothingness, a void so vast and so empty that it pushes our galaxy through space by the simple, haunting fact of not being there. This is what we are going to explore together in the quiet hours as the world settles around you and sleep begins to gather at the edges of your awareness. Not the things that are out there in the universe, but the thing that is not, the great empty place behind us, the Dipole Repeller, the cosmic nothing that has been doing its silent work since before the Earth existed, and will continue long after it is gone. The year was 1986, and a group of astronomers did something that sounds simple but was, at the time, quietly revolutionary. They measured the motion of our galaxy with enough precision to ask a real question about it. They had noticed something puzzling in the cosmic microwave background radiation. This is the faint afterglow of the Big Bang itself, a kind of cosmic wallpaper that fills the entire universe. Ancient light stretched thin by billions of years of expansion. When you map this background radiation, it should look more or less the same in every direction. And it does, almost. But there is a subtle difference. In one direction, the background radiation appears very slightly warmer. In the opposite direction, it appears very slightly cooler. This asymmetry has a name. It is called the CMB dipole, and it tells us something profound. It tells us that we are moving relative to the background of the universe itself, moving toward the slightly warmer side and away from the slightly cooler side. The question that haunted astronomers was simple. Why? What is pulling us in that direction? The answer, when it came, was dramatic. In the direction of the constellations Centaurus and Hydra, hundreds of millions of light years away, something enormous lurked. A concentration of mass so immense that it was pulling not just our galaxy, but the Milky Way, Andromeda, and dozens of other galaxies all together, like beads sliding along a wire, drawn inexorably toward a single gravitational center. They called it the Great Attractor. The name alone carries a kind of weight. The Great Attractor. It sounds like something from mythology, some ancient god of gravity sitting in the dark, patient and immense, drawing everything toward it with a force so powerful that not even the expansion of the universe can fully overcome it. And in a sense, that is not far from the truth. The Great Attractor sits at the heart of what we now call the Hydra-Centaurus Supercluster, a region containing hundreds of thousands of galaxies, bound together by gravity into a structure that is almost beyond comprehension. Its total mass is estimated to be on the order of 10,000 times the mass of the Milky Way. The gravitational influence it exerts extends across hundreds of millions of light years in every direction. But here is what made the Great Attractor maddening to study for so long. It sits almost exactly in the plane of our own galaxy. And the plane of the Milky Way is full of dust, gas, and stars, all of which block our view. Trying to observe the Great Attractor from Earth was like trying to see a city skyline through a thick fog, with someone shining a flashlight directly into your eyes. We knew something was there. We could feel its pull and the motion of our galaxy, but we could not see it clearly. For years, astronomers worked around this problem, using radio waves and infrared light, which can penetrate the dusty plane of the galaxy better than visible light. Slowly, a picture emerged, not just a single massive concentration of galaxies, but a larger structure, one that ultimately led to the mapping of our entire supercluster, Laniakea, a word from the Hawaiian language meaning immeasurable heaven. Laniakea, as we now understand it, is a supercluster of galaxies spanning roughly 520 million light years. It contains more than 100,000 galaxies. Its total mass is approximately 100 million billion times the mass of our Sun, and the Milky Way sits near its outer edge, like a small town on the outskirts of an incomprehensibly vast city. The Great Attractor sits near the center of Laniakea. It is the gravitational heart of our cosmic neighborhood. And for decades, astronomers believed that if you wanted to explain why we were moving in the direction we were moving, the Great Attractor was the answer. It was a satisfying answer. It was a dramatic answer. A vast hidden mass, drawing our galaxy across hundreds of millions of light years, across hundreds of millions of years. A gravitational story of pull and inevitability. But it was not the whole story, because when scientists looked more carefully at the numbers, they found a problem. The Great Attractor, for all its immensity, did not fully account for the speed at which we were moving. Something else was contributing to our motion. Something else was adding to the push. And when they turned to look in the opposite direction, in the direction away from the Great Attractor, in the direction we were moving away from, they found not a competing mass, not a rival cluster of galaxies. They found an absence, a vast, almost featureless emptiness, a void so immense that it seemed to swallow light and matter alike, leaving almost nothing behind. It was not pulling us. It was not attracting us. It was repelling us. Or rather, its absence was repelling us in the strangest, most counterintuitive way that physics allows. To understand how that is possible, we need to think carefully about what gravity really does, and what happens when there is almost no gravity at all. But before we do that, let us sit for a moment in what we have just discovered. The Great Attractor, this monumental structure that astronomers spent decades trying to see through the fog of our own galaxy, was only half the equation, half the force shaping our journey through the cosmos. The other half was hiding in plain sight, in the dark, in the nothing. There is a thought experiment that I would like you to try, even here, even as you are drifting towards sleep. It requires almost no effort. It is simply a matter of imagination. Imagine a river, not a fast river, not a violent or churning river, a slow, immense river, broader than any river on Earth, moving with a quiet and irresistible inevitability. You are floating on this river. You have always been floating on it. And as you float, you watch the bank on one side, where you are heading, growing gradually closer. You can see something there, something large and dense, a great city of matter rising up on that shore. It is pulling you in. Its gravity reaches across the water and draws you steadily forward. For a long time, that is the whole story. You are being pulled. The current carries you. The city on the far shore draws you closer. This seems like a complete explanation. But then, very quietly, you become aware of something else. A sensation at your back. Not the pull of the city ahead, but something different. A kind of pressure, a gentle but constant push, coming from behind you. And when you turn to look at what lies behind you, upriver, in the direction you came from, you do not see another city. You do not see another great mass of matter. You see nothing, an enormous, featureless expanse, a desert of water, if such a thing can be imagined, an emptiness so profound that it seems to stretch forever. And yet the push is real. The push is measurable. The push has been acting on you for as long as you can remember. This is, in essence, what cosmologists discovered about our galaxy's motion. For decades, we knew about the river. We knew about the Great Attractor on the shore toward which we were moving. We understood the pull, but we had not fully reckoned with the push. We had not looked back upstream, into the emptiness that lay behind us, and asked whether that emptiness itself was contributing to our motion. The oversight was not a failure of intelligence. It was a failure of imagination, in the most forgivable sense. We are creatures who think in terms of presence. We look for things. We measure things. We name things. The idea that an absence, a genuine, vast, gravitational absence, could actively shape the motion of galaxies was not something our intuitions were built to grasp. And yet, when you think about it carefully, it makes a kind of deep and haunting sense. Gravity works by pulling matter toward matter. Where matter is dense, the gravitational pull is strong. Where matter is sparse, the gravitational pull is weak. Now imagine standing in a region where matter is distributed unevenly around you. On your left, there is a great concentration of mass, pulling you to the left. On your right, there is almost nothing, very little mass, very little gravitational pull. The net effect is that you are pulled to the left, not just by the mass on the left, but also by the relative absence of mass on the right. The void on your right is not pushing you, but by failing to pull you equally, it is allowing the mass on the left to dominate. The result feels like a push. This is what physicists mean when they talk about the dipole repeller as a repelling force. It is not a source of some mysterious anti-gravity. It is not a place where the laws of physics break down. It is something more subtle, and in some ways more unsettling. It is a place where the ordinary work of gravity is simply absent, where matter has not gathered, where the cosmic web has not woven its threads, and by its absence, it has shaped the motion of our entire local group of galaxies for billions of years in a direction away from it. We were not just being pulled toward the Great Attractor. We were being pushed away from the Great Nothing. And we did not know this, not with certainty, not with the full weight of scientific evidence, until 2017. The discovery came from a team of astronomers led by Yehuda Hoffman at the Hebrew University of Jerusalem. They were working on one of the most ambitious projects in modern cosmology, a detailed three-dimensional map of the velocities of galaxies in our local universe. Not just where galaxies are, but how fast they are moving and in which direction. By combining this data, they could reconstruct the gravitational landscape of our cosmic neighborhood, inferring the distribution of mass from the flows of galaxies, the way a detective infers the shape of a river's bottom from the patterns of its current. What they found was a picture of extraordinary complexity, and at its center, there was not just one dominant feature. There were two. On one side, the Great Attractor, familiar and imposing, and on the other side, something new, something vast and empty, sitting in the direction of the constellations Vela and Puppis, roughly 600 million light-years away. A region of dramatically lower than average galaxy density, a void of immense proportions, a dipole repeller. The name comes from the concept of a dipole, two poles of opposite character, like the north and south poles of a magnet. In this case, one pole attracts and one pole repels. One pole draws our galaxy toward it, and one pole pushes our galaxy away from it. Together, they create the river we are floating on. Together, They explain the full magnitude of our motion through the cosmos. The paper announcing the discovery was published in the journal Nature Astronomy. Its title was quiet and precise, as scientific papers tend to be, but what it described was anything but quiet. It was a fundamental shift in our understanding of where we are and why we are moving the way we are moving. For the first time, we had a complete picture, or at least a more complete picture. We were not just falling towards something. We were also fleeing from something, and that something was nothing. Before we go deeper into what the dipole repeller is and what it means, I want to take a moment to appreciate how we found it at all, because the story of its discovery is also a story about the limits of human perception and about the extraordinary tools we have built to see beyond those limits. The problem, at its heart, is this. The universe is three-dimensional, but the sky, as we see it, is two-dimensional. When you look up at the night sky, you see stars and galaxies projected onto a flat dome. You can tell which direction something is in, but not how far away it is. Distance, in astronomy, must be inferred, and it must be inferred through measurements that are, each in their own way, indirect. For galaxies, one of the most powerful tools for measuring distance is redshift. When a galaxy is moving away from us, the light it emits is stretched. Its wavelengths become longer, shifting toward the red end of the spectrum. The faster it is moving away, and in an expanding universe, the more distant a galaxy is, the faster it recedes, the more its light is redshifted. By measuring the redshift of a galaxy's light, astronomers can calculate how fast it is moving away from us, and from that, estimate its distance. But here is the complication. The recession velocity of a galaxy, the speed at which it seems to be moving away from us, is not a clean measurement. It has two components. First, there is the expansion of the universe itself, which causes all distant galaxies to recede from us simply because space is expanding. Second, there are what astronomers call peculiar velocities. These are the extra motions of galaxies caused by gravity, by the pull of nearby clusters, by the push of nearby voids. These peculiar velocities are the fingerprints of the gravitational landscape. They are what Hoffman and his team were trying to map. The challenge is separating these two components. If you know a galaxy's distance precisely, you can calculate how fast it should be receding due to expansion alone and subtract that to find its peculiar velocity. But measuring precise distances to galaxies is notoriously difficult. Each method has uncertainties. Each method has its own sources of error. Hoffman's team used a dataset called cosmic flows, a catalog of thousands of galaxies with carefully measured distances. By combining this with redshift measurements, they could reconstruct the peculiar velocity field of our local universe. A map not just of where galaxies are, but of how they are flowing through space. And from this flow map, they could infer the underlying distribution of matter, like reading the currents of a river to understand the shape of its bed. The result was a reconstruction of extraordinary detail. Filaments and clusters emerged on one side. Voids and underdense regions appeared on the other. And when they decomposed the forces acting on our local group into their components, one thing became clear. The Great Attractor alone was not sufficient to explain our motion. There had to be a repelling component as well. And that component was centered on a massive underdense region, a void, sitting in roughly the opposite direction from the Great Attractor in the sky. They called it the Dipole Repeller. What struck many readers of that paper was not just the finding, but the elegance of the method. They had found a massive void not by seeing it directly, not by observing what was in it, but by observing how other galaxies were moving around it. By reading the current of the river, they had found the hole in the riverbed. They had discovered something by its absence. This is, in many ways, a metaphor for how we understand the universe at its largest scales. We cannot see dark matter. We cannot see dark energy. We infer their existence from the way visible matter moves, from the way light bends, from the way the universe expands. The universe has a habit of hiding its most important features from direct view, offering instead only indirect signatures, clues in the behavior of things we can see. The Dipole Repeller was found in exactly this way, a ghost detected by the shadows it cast in the motion of galaxies. And what a ghost it is! The Dipole Repeller sits roughly 600 million light years away from us. To travel that distance at the speed of light would take 600 million years. When that light was first emitted, life on Earth was only just beginning to experiment with hard shells and complex bodies. The Cambrian explosion, one of the most dramatic events in the history of life on this planet, had not yet occurred. And yet, in those 600 million years, the light traveling toward us from that direction has been moving through a region that is, by cosmic standards, astonishingly empty. It is not a perfect void. Like other great cosmic voids, it is not truly devoid of everything. There are some galaxies within its boundaries. There is some gas, some dark matter, some structure. But compared to the surrounding universe, compared to the dense filaments and clusters that define the cosmic web, it is extraordinarily sparse. Its density of matter is dramatically below the cosmic average. And it is that underdensity, that relative absence of gravitational pull, that makes it what it is. A repeller, an anti-attractor, the empty pole of our cosmic dipole. We have been moving away from it and toward the Great Attractor for billions of years. Our grandchildren and their grandchildren and every generation of humanity that has ever existed and ever will exist will live and die during a tiny fraction of the time it takes for the Milky Way to make any measurable progress on this journey. The motion is real. The forces are real. But they operate on a timescale that makes human history seem like the blink of an eye. And yet, here we are, in this quiet room, in this still moment, with this extraordinary knowledge. We know that there is a vast nothingness behind us. We know that it is pushing us forward. We know that we are caught in a cosmic river, between an emptiness that repels and a fullness that attracts. And we know, now, that for all the centuries we spent looking at the sky and wondering what moved the stars, we were only ever seeing half the picture. The other half was invisible. It was silent. It was empty. And it was the most powerful thing in our cosmic neighborhood. There is a particular beauty in that last sentence that I want to sit with for a moment before we move on. The most powerful thing in our cosmic neighborhood is not a thing at all. It is the absence of things, the empty pole of our cosmic dipole, the void that pushes while the attractor pulls, the nothing that, by its very nothingness, shapes the path of 100,000 galaxies. Humanity has spent most of its history looking for power and presence, in mountains and storms and floods, in armies and governments and great accumulated masses of people, in stars and black holes and the dense hearts of galaxy clusters. We are drawn to the visible sources of force. We want to see the thing that is doing the work. We want to point to it and name it and understand it. And then the universe, in its particular and uncooperative way, shows us that the most powerful force in our neighborhood is an absence, is a quiet, is a vast 600 million light-year emptiness that exerts its influence not by doing anything, but by failing to hold, by failing to pull, by letting matter flow away from it, into the waiting arms of the Great Attractor on the other side. This is what we are going to spend the rest of tonight exploring, the nature of this emptiness, its origin, its scale, its relationship to everything else in the cosmic landscape, the way it fits into the larger story of how the universe is structured, and how our galaxy found itself in this particular river, between this particular void and this particular attractor, moving in this particular direction at this particular speed. By the end, I hope you will have a different relationship with emptiness, Not fear, not unease, but something closer to recognition. The recognition that absence is not the opposite of presence, that nothingness is not the enemy of something, that the void is not a hole in the universe, but a feature of it, a participant in its story, a force in its own right. Rest now into the telling. The night is long enough. The universe is patient, and the Dipole Repeller, 600 million light years away, is doing its slow and silent work, as it always has, as it always will. There is a word we use for the great empty regions of the universe. We call them voids. It is a simple word, almost too simple for what it describes. When most people hear the word void, they picture something passive, something inert, an emptiness that simply sits there, waiting, doing nothing, a blank space on the map, a silence between notes. But a cosmic void is not passive. It is not inert. It does not simply sit there. It acts. It shapes. It pushes. And to understand how, we need to think carefully about the nature of gravity and about what happens when the expected amount of gravity is simply not there. Let us begin with a thought experiment, a simple one, that I think will make this clearer than any equation could. Imagine you are standing in the middle of a field. Around you, in every direction, there are hundreds of people, spread roughly evenly across the landscape. Each of those people exerts a tiny gravitational pull on you. The pulls from all directions roughly cancel each other out, and you feel no net force. You stand still. This is, in a crude sense, what a uniform universe would feel like. Matter distributed evenly, gravitational pulls canceling each other out, no net motion in any direction. Now imagine that someone quietly removes all the people from one half of the field. The left half, let us say, is now empty. The right half still has all those people, exerting their small gravitational pulls. What happens to you? You are no longer in equilibrium. The pulls from the right are no longer balanced by pulls from the left. You begin to drift to the right, toward the people, away from the emptiness. Now here is the key insight. The emptiness on the left did not push you. There is nothing there to push. But the net effect of its absence is indistinguishable from a push. You move away from it, just as surely as if something were shoving you. The void, by failing to pull you, allows the matter on the other side to dominate. And domination, in physics as in life, has consequences. This is the fundamental mechanism behind the Dipole Repeller. It is not a source of exotic force. It is not a place where anti-gravity reigns. It is simply a region of dramatically lower than average matter density, sitting in one direction from us, while the Great Attractor sits in the roughly opposite direction. The Great Attractor pulls. The Dipole Repeller fails to pull. And the net result is a motion, a powerful, sustained, billion-year motion, directed away from the void and toward the cluster. But there is more to the story. Because the universe is not static. It is not frozen. The cosmic web is alive in its slow and vast way, evolving over time. And voids do not merely sit there in their emptiness. They grow. As matter flows out of underdense regions and into denser ones, drawn by gravity toward clusters and filaments, the voids become emptier still. The matter that was once in them has left. The galaxies that might have formed there never did. And the gravitational landscape becomes more and more extreme over time. The rich get richer. The empty get emptier. This means that the Dipole Repeller is not the same today as it was a billion years ago. It is, if anything, more empty, more extreme. The relative absence of matter within it is more pronounced now than it was when the first complex life was forming on Earth. And it will become more pronounced still as the universe continues to evolve. Dark energy plays a role in this as well. Dark energy, the mysterious force that is driving the accelerating expansion of the universe, tends to dominate in regions of low matter density. In the dense clusters, The gravity of matter partially counteracts the expansion. But in the voids, where matter is scarce, dark energy acts almost unopposed. It stretches space more rapidly there. It expands the void from within, making it larger, emptier, and in some ways more powerful in its repelling effect, even though that repulsion is always just the absence of attraction. So a void like the Dipole Repeller is not a relic. It is not simply a leftover hollow from the early universe. It is a living feature of the cosmic landscape, growing and deepening as billions of years pass. It is an absence that becomes more absent with time, a silence that becomes quieter, a nothing that becomes more thoroughly nothing. And against that growing nothing, our galaxy moves, has moved, will continue to move. For astronomers, this makes voids extraordinarily useful. They are, in a sense, the negative space of the cosmic web, and negative space is often the most revealing kind. By studying where galaxies are not, we learn about the forces that shaped where they are. By measuring the flows of galaxies around a void, we can infer its properties, its size, its depth of underdensity, and its influence on the surrounding universe. The Dipole Repeller, found this way by reading the current of the river rather than by seeing the hole in the riverbed, is a perfect example of this principle. But beyond the science, there is something philosophically arresting about a void that acts. We are accustomed to thinking of presence as the source of all influence. We believe that things cause effects, that matter shapes the world, that energy drives change. The void challenges this. It says that absence, too, can cause effects, that nothingness, too, shapes the world, that the empty space in the universe is not merely the backdrop against which matter performs its drama. It is a participant in that drama. And if that is true of the universe, it may be worth asking whether it is true in other domains as well. Whether the silences in a piece of music are as important as the notes. Whether the spaces in a painting are as meaningful as the painted areas. Whether the pauses in a life are as formative as the events. But those are questions for another kind of night. For now, let us simply rest with this. The universe contains a vast emptiness that has been shaping our path for billions of years. And we are only just beginning to understand what a void can do. I keep returning to the image of the river because I think it is the most honest metaphor we have for what is happening to our galaxy. A river is not just water. It is a story of forces. The water flows because of gravity, yes, but also because of pressure gradients, because of the shape of the land, because of the presence of elevation on one side and the promise of lower ground on the other. The water does not choose to flow. It is simply following the path of least resistance, responding to the contours of a landscape it did not create. Our galaxy is the water, and the landscape, the contours of the gravitational terrain through which we flow, is shaped by two features working in concert. On one side, the Great Attractor and the immense structure of Laniakea, pulling with the weight of millions of galaxies, drawing us forward with a gravity that is patient and irresistible. On the other side, the Dipole Repeller, the great empty pole of our cosmic dipole, failing to hold us, failing to match the pull from the other direction, allowing us to be swept away. We are flowing between nothing and everything. And what makes this image so haunting, what gives it its particular flavor of cosmic unease, is the fact that we are not steering. We have no hand on the tiller. We are not choosing our direction. We are simply moving, as all water moves, as all matter moves, following the grooves carved into the universe by billions of years of gravitational evolution. The motion has been underway for a very long time, long before the Earth existed, long before the sun ignited, long before the first complex molecule arranged itself into something that could be called life. The river was already flowing. The landscape was already shaped. We were born into a current that was ancient before we arrived. This is perhaps the most dizzying aspect of the Dipole Repeller story. Not its size, though its size is staggering. Not its distance, though its distance is beyond easy comprehension. It is the sheer age of the process. The Dipole Repeller has been shaping our galaxy's path, in concert with the Great Attractor, for billions of years. Every single ancestor you have ever had, every organism in the long chain of life that connects the first cells on Earth to you, lying here tonight, has lived and died during this journey, has been part of this motion, without knowing it, without feeling it, without any awareness that they were passengers in a cosmic river flowing between the greatest emptiness and the greatest fullness in our celestial neighborhood. There is something both terrifying and strangely comforting in this. Terrifying because it reminds us how utterly beyond our control the largest forces in our lives really are. We like to think of ourselves as agents, as beings who make choices, who shape our paths. And on the scales that matter to us, the scales of days and years and lifetimes, we do. But on the scale of the cosmos, we are water. We flow. We do not decide. Comforting, because there is something restful about surrendering, even in imagination, to a current so vast that resistance is meaningless. The river flows whether we fight it or not. The galaxy moves whether we are awake or asleep. The universe is doing its enormous work regardless of our attention. And in that indifference, there is a kind of peace. We do not need to manage the river. We only need to float. The river metaphor also helps us understand the coherence of the motion. It is not just the Milky Way that is moving in this direction. It is all the galaxies in our local group. Andromeda, our closest large galactic neighbor. The Triangulum Galaxy. Dozens of smaller satellite galaxies. All of them are flowing in the same direction, at roughly the same speed, responding to the same gravitational landscape. We are not alone in the river. We are part of a fleet of galaxies, all being swept in the same direction, all caught between the same push and the same pull. And beyond our local group, the effect extends further. The Dipole Repeller and the Great Attractor are not local features. They are part of the large-scale structure of the universe. The gravitational flows they generate affect galaxies across hundreds of millions of light years. The cosmic river is not a small stream. It is one of the grandest currents in the observable universe. When Hoffman and his team published their map of these flows, what emerged was a picture of extraordinary beauty. Arrows indicating the direction and speed of galaxy motion, arranged across vast stretches of the cosmic web, converging toward the Great Attractor from all sides, diverging away from the Dipole Repeller in all directions, and threading between them. Our local group, our small fleet of galaxies, flowing along the path that the landscape had carved for us. It looked like a weather map of the cosmos. High pressure and low pressure, wind and current, all on a scale that dwarfs any weather system Earth has ever known. And at the center of the image, tiny, almost invisible, the Milky Way, our home, moving through it all without a word. There is a version of this story that is frightening. The version where you focus on the scale, on the indifference, on the powerlessness, where the river becomes a symbol of how small we are and how little our choices matter against the backdrop of forces this immense. But there is another version. The version where you recognize that being carried by a current this vast is not diminishment. It is participation. We are not outside the universe, watching it happen. We are in it, part of it, flowing with it. The river is not carrying us away from anything that matters. It is carrying us through the universe, the only universe we have, the one that made us, the one that holds us, the one that is doing its slow and magnificent work all around us, every second of every day, whether we sleep or wake. So let the current carry you, not just tonight, not just in this moment of rest, but always, because the river is always flowing, and you are always in it. And that is not a cause for fear. It is simply the truth of where you are. I have mentioned the number before, but I want to come back to it now because it deserves a moment of quiet attention. 630 kilometers per second. That is roughly how fast our local group of galaxies is moving relative to the cosmic microwave background, the great background radiation that fills the universe. 630 kilometers per second. Let us try to make that number real. The speed of sound in air is about 343 meters per second. Our galaxy is moving through the cosmos at roughly 1,800 times the speed of sound. If you could travel at this speed, you could cross the entire width of the continental United States, from New York to Los Angeles, in approximately 7 seconds. The speed of light is about 300,000 kilometers per second. Our galaxy is moving at roughly 1/5 of 1% of the speed of light. That sounds slow when you put it that way. But remember what we are talking about. Not a spacecraft, not a particle in an accelerator. A galaxy, an island of 400 billion stars, along with all their planets, their moons, their asteroids, their clouds of gas and dust, their enormous halo of dark matter. Everything moving at 630 kilometers per second, 2,268,000 kilometers per hour. Every hour, our galaxy moves more than 5 times the distance from the Earth to the Moon. Every day, it moves more than the distance from the Earth to the Sun. Every year, it travels a distance that is almost incomprehensible to imagine, and it has been doing this for billions of years. How far have we traveled? The calculation requires knowing how long the motion has been sustained at roughly this rate, which is complicated because the rate changes over time as the gravitational landscape evolves. But rough estimates suggest that our galaxy has been displaced by this bulk flow by hundreds of millions of light years over the course of cosmic time. The journey is not over. It will not be over for an incomprehensibly long time. But we are well into it. We have been on this river for longer than the Earth has existed. When you try to hold the scale of the push in your mind, something interesting happens. The mind, initially, simply refuses. The numbers are too large. The distances are too great. The timescale's too vast. And so the mind does what minds do when they encounter something truly too large to process. It retreats. It miniaturizes. It finds a way to make the thing small enough to hold. But there is a way to feel the scale without fully comprehending it. Not by grasping the number, but by grasping the proportion. 630 kilometers per second sounds like a lot, and it is. But the distances involved in the story of the Dipole Repeller are so immense that even at this speed, even maintained for billions of years, our galaxy has only just begun to move across the gravitational landscape. We are like a leaf on a river. Moving, yes. Moving faster than we can truly feel. But the river is so long, the distance between its source and its end so vast, that the leaf barely seems to move at all against the scale of the whole. This is one of the qualities of the universe that I find most difficult to hold in my mind, and most rewarding when I try. The coexistence of enormous speed and enormous stillness. We are hurtling through space at 2 million kilometers per hour, and we feel absolutely nothing. We feel still. We feel at rest. The universe is doing something immense, and it is doing it in such a way that we cannot feel it at all. The push is real, and it is powerful, and it is silent. The Great Attractor contributes something like 40% of our total peculiar velocity. The Dipole Repeller contributes roughly the remaining 60%, or at least, that is what the current best estimates suggest. The repeller, the nothing, the empty pole of our cosmic dipole, is actually the slightly larger contributor to our motion. We are being pushed more than we are being pulled. The void is, in this accounting, slightly more powerful than the attractor. Think about what that means. The nothingness behind us is exerting a greater influence on our path through the universe than the colossal supercluster ahead of us. Absence is winning in the tallying of forces. The empty side of the equation is heavier. There is something almost philosophical about that. We think of mass as the source of gravitational power. We think of presence as the basis of influence. And yet here, in the most concrete and measurable way possible, absence has the upper hand. The void is more powerful than the cluster. Emptiness is more forceful than fullness. How far away is the Dipole Repeller? About 600 million light years. How far away is the center of the Great Attractor's influence, the heart of the Laniakea Supercluster? Roughly 250 million light years. The repeller is more than twice as far away, and yet its contribution to our motion is, by some estimates, slightly larger. This gives you some sense of how vast and deep its underdensity must be to produce such a powerful effect at such a distance. It is not a small absence. It is an enormous, profound, and deepening absence, and its gravitational shadow falls across hundreds of millions of light years. We are being pushed by something that is twice as far away as what is pulling us, and being pushed more strongly. And what is pushing us is nothing. The scale of the push is not just a number. It is a story about the kind of universe we live in. A universe where the absence of things can be more powerful than their presence. Where the void can outweigh the cluster. Where nothing can win against everything. And we are proof of it. Moving through space at 2 million kilometers per hour, pushed by the dark, drawn by the light, flowing between them in the grandest river we have ever had the privilege of knowing about. I want to give you a new way of thinking about the relationship between the Great Attractor and the Dipole Repeller, because the river metaphor, as beautiful as it is, does not quite capture the symmetry of the arrangement. For that, I think we need a different image. Think of a magnet. An ordinary bar magnet has 2 poles, north and south. At the North Pole, magnetic field lines emerge and curve outward. At the South Pole, they curve inward and enter. An object placed near the magnet will be influenced by both poles simultaneously, attracted toward one and repelled from the other, depending on its own magnetic character. The magnet works as a unit. You cannot have just a North Pole without a South. The 2 poles define each other. They create the field together. The Great Attractor is, in this metaphor, the South Pole of our cosmic magnet, the place toward which the field lines flow, the place of convergence, of accumulation, of gravitational concentration. Galaxies flow toward it the way magnetic field lines flow toward the South Pole, not because they choose to, but because the landscape of forces demands it. And the Dipole Repeller is the North Pole, the place from which the field lines emerge, the place of divergence, of departure, of repulsion, not repulsion in the magnetic sense, not a force that actively pushes, but repulsion in the gravitational sense, a place that fails to pull, and so allows everything around it to be pulled away. Together, the Great Attractor and the Dipole Repeller form what physicists call a gravitational dipole. 2 poles of opposite character, separated by hundreds of millions of light years, creating a field of motion that influences everything in their vicinity. A cosmic magnet, written not in iron and magnetism, but in matter and its absence. Now, here is what makes the anti-magnet metaphor so potent. You can feel a magnetic field. If you have ever held 2 magnets and felt them push apart, you know the sensation of magnetic repulsion. It is direct. It is physical. You are aware of it. But you cannot feel the gravitational dipole of the Dipole Repeller. You cannot feel the push of the void. You cannot feel the pull of the Great Attractor. These forces are real. They are measurable. They are shaping your path through the cosmos at this very moment. But they are completely imperceptible to you, completely beyond your senses. This is one of the most haunting qualities of the Dipole Repeller. Not just its size, not just its emptiness, but its absolute invisibility to ordinary experience. You are being pushed by it right now, as you read these words, as you breathe, as your eyes grow heavy. You have been pushed by it every moment of your life, and you have never felt it. Not once, not even slightly. The forces that shape our largest scale motion through the universe are entirely hidden from us. We can only find them through elaborate measurement, through the careful mathematics of velocity fields and distance catalogs, through the kind of patient, intricate scientific work that takes decades to complete. Without that work, without that extraordinary human effort to see beyond the limits of perception, the dipole repeller would be invisible forever. We would move through its influence without any awareness that it existed. And this raises an uncomfortable question. If a force this large can be entirely invisible to us, what else is invisible? What other influences are acting on us, shaping our path, pushing and pulling us in ways we have not yet had the tools to detect? What other anti-magnets are hiding in the dark, doing their silent work? It is a question science takes seriously. And the honest answer, for now, is that we do not know. Our maps of the cosmic velocity field are improving, but they are still incomplete. Our understanding of the large-scale structure of the universe, beyond what we can currently observe, is limited. The dipole repeller is the largest such feature we have identified in our local cosmic neighborhood. But the universe extends far beyond what we can see. And the universe has no obligation to stop producing surprises at the edge of our current vision. The anti-magnet sits 600 million light-years away. It is silent. It is invisible. It is enormously powerful. And it is one of the most compelling discoveries in modern cosmology, not just because of what it tells us about the large-scale structure of the universe, but because of what it tells us about the limits of our perception. We found it only because we built instruments sensitive enough to measure the peculiar velocities of thousands of galaxies. We understood it only because we had the mathematical tools to decompose a complex velocity field into its constituent forces. We named it only because we had a conceptual framework rich enough to accommodate the idea of a void that acts. All of that knowledge, all of that capability, was built up over generations of astronomers, each contributing a small piece to a picture that none of them could see in full. The discovery of the dipole repeller is, in this sense, a monument to the cumulative power of human curiosity. A monument made not of stone or steel, but of data and equations and patient observation. A monument to the idea that nothingness can be found and named and understood. And the thing that was found, the anti-magnet, the empty pole of our cosmic dipole, is pushing us even now, silently, invisibly, without pause. I want to ask you a strange question as you rest here in the dark. What does nothing weigh? It sounds like a riddle, a trick question designed to lead you to the obvious answer. Nothing weighs nothing. By definition, nothing is the absence of everything, including weight. But the universe, as we have been discovering together, does not honor our definitions. In the universe, nothing is not as simple as we imagine. In the universe, nothing has consequences. Nothing has effects. Nothing, in a very real and measurable sense, has weight. Not physical weight, not mass in the conventional sense, but gravitational consequence. The dipole repeller, this vast region of dramatically lower than average matter density, exerts an influence on the motion of our galaxy that is, by current estimates, slightly larger than the influence of the Great Attractor. It shapes our path through the cosmos. It has done so for billions of years. Its influence is not zero. It is not negligible. It is, in fact, the dominant force shaping our peculiar velocity. And that influence arises from absence, from the fact that matter is not there, from the weight of nothing. Philosophers have wrestled with nothingness for as long as there have been philosophers. The ancient Greeks debated whether a true vacuum could exist. The nothing was deeply controversial, philosophically speaking, because if something is nothing, then how can you say anything about it? How can you name it, describe it, discuss it? The moment you say the word void, you have made it something. You have given it an identity, a position, a character. The universe, it turns out, has been ahead of philosophy on this point. The universe has always known that voids are not simply absences. They are features. They are participants. They have character and consequence. The dipole repeller does not just sit there being empty. It is doing something. It is shaping the universe around it by the specific, particular nature of its emptiness. The weight of nothingness, in this cosmic sense, is the weight of all the mass that is not there. If you take a region of space that should contain, based on the average density of the universe, a certain amount of matter, and that matter is absent, then the missing gravity of that missing matter has real consequences. The galaxies around the void flow away from it, not pulled away by some active force, but simply failing to be held, failing to be pulled in, slipping away, like sand through fingers that aren't there to close. This is a strange way to think about force. We are accustomed to thinking of force as something applied, something exerted, an action that requires an actor. But the dipole repeller suggests a kind of force through an action, through the simple failure to do what average matter would do. Its power is the power of an expected presence that does not show up. Let me try to give this an emotional weight, a human resonance. Think of a room where someone was supposed to be. A room set for a dinner guest who never arrived. The empty chair, the untouched place setting, the silence where conversation should have been. The absence of that person does not do nothing to the room. It does something. It changes the atmosphere. It redirects attention. It shapes the behavior of everyone present. The missing person has, through their absence, exerted an influence. Now imagine that absence scaled up. Not one missing person, but billions of missing galaxies, billions of missing stars. The gravitational pull that would have existed had all that matter been there, simply not existent. And the universe, which is nothing if not responsive to the balance of forces, responds. Matter flows away from the absence toward the presence. The void grows, the attractor accumulates, and the river between them deepens and flows. The weight of nothingness is the weight of what is missing, computed in the currency of gravity, measured in the motion of galaxies. It is a weight that can be calculated, a weight that has been calculated, and it is heavier than you might expect. There is a poetic truth buried in all of this. We often speak of the weight of absence in our lives, the weight of grief, which is the absence of someone we loved, the weight of regret, which is the absence of choices we did not make, the weight of loneliness, which is the absence of connection. These absences are real. They are felt. They shape us. They push us in directions we would not otherwise have gone. The universe, in its vast and indifferent way, is telling us something similar. Absence has weight. The things that are not there matter. The voids shape the structure. The nothing exerts the push. What nothingness weighs, in the end, depends on what it replaces. In a universe where matter is expected, the absence of matter creates an imbalance. And imbalance, in a universe governed by gravity, always has consequences. The dipole repeller weighs as much as the matter that should have been there, but is not. And that weight, applied over billions of years, has moved our galaxy further than most humans can imagine. Rest now with that thought. The nothing behind you, 600 million light years away, has been doing its silent work since before the Earth existed. It weighs nothing, and it weighs everything. It is absent, and it is present in its effects. It is the empty pole of our cosmic magnet, and it is one of the most powerful forces in our celestial neighborhood. And tonight, as you sleep, it will continue its work, pushing, silently, without pause, without awareness, as it has always done, as it will always do. Before we can fully appreciate what it means to be pushed by the Dipole Repeller, we need to understand where we are, not just in the Milky Way, not just in the local group, but in the larger structure that contains all of this. The ocean in which we swim, the supercluster we call home. Its name is Laniakea. The word comes from the Hawaiian language, and it means immeasurable heaven. It was chosen by the team of astronomers, led by Brent Tully at the University of Hawaii, who first mapped it in 2014. The name is fitting, because Laniakea is, by almost any human standard of measurement, immeasurable. Let me try to give you its scale. Laniakea is a supercluster of galaxies. Not just a cluster, not just a group, but a supercluster. A vast, gravitationally defined region of the universe containing tens of thousands of individual galaxies. Its diameter is approximately 520 million light-years. A beam of light, traveling at the fastest speed anything can travel in this universe, would take 520 million years to cross it from one side to the other. It contains more than 100,000 galaxies. Its total mass is approximately 10 to the power of 17 solar masses. That is 100 million billion times the mass of our Sun. A number so large that it has no intuitive meaning. A number that the human brain simply cannot hold. And the Milky Way, our galaxy, sits near the outer edge of it. Not at the center, not near the heart, but at the periphery, like a small village on the outskirts of an enormous city. Like a single house on the edge of a continent. Laniakea was mapped using the same technique that would later reveal the Dipole Repeller. By tracking the peculiar velocities of galaxies, by mapping which way they were flowing, astronomers could define the boundaries of the supercluster. The boundary is the watershed, the line beyond which the flows no longer converge toward the center, but diverge away from it. Laniakea is defined by the region from which all the gravitational currents flow inward toward the Great Attractor at its heart. Think of a watershed on Earth. Rain falls on a mountain range. On one side of the ridge, the water flows down to one river system. On the other side, it flows down to another. The ridge is the watershed, the boundary, the line that determines which ocean the water will eventually reach. In the same way, Laniakea is bounded by the gravitational watershed that determines which galaxies flow toward its center and which flow away. The Milky Way is inside Laniakea. We are part of its flow. Our peculiar velocity is directed, in part, toward the Great Attractor at Laniakea's heart. We are, in the most literal sense, a member of this supercluster, a resident, a participant in its slow gravitational story. But we are not at the center. We are not near the center. We are small, and we are peripheral, and we are surrounded by a structure so immense that most of it is invisible to our unaided eyes. The galaxies of Laniakea are mostly too faint and too distant to see without telescopes. The structure itself can only be perceived through the painstaking mapping of velocities, through the kind of mathematical reconstruction that turns motion into map. And yet Laniakea is our home. In the same way that Earth is our home, that the Milky Way is our home, that the local group is our home. We are nested within it, like a matryoshka doll of cosmic structures, each containing the last, each dwarfing the last, each making the last seem smaller by contrast. The Earth is roughly 12,000 kilometers across. The solar system is roughly 8 light-hours across, in terms of the planetary orbits. The Milky Way is roughly 100,000 light-years across. The local group spans roughly 5 million light-years. Laniakea spans 520 million light-years. At each step, the scale multiplies by a factor that makes the previous scale feel microscopic. The Earth in the solar system is a marble in a football field. The solar system in the Milky Way is a grain of sand on a beach. The local group in Laniakea is a single cell in a human body, and Laniakea, for all its immensity, is just one supercluster among many, just one knot in the cosmic web, just one feature in an observable universe that stretches 93 billion light years in diameter. We are very, very small, but here is what I want you to hold on to, even as the scale threatens to overwhelm. The Dipole Repeller is not inside Laniakea. It lies beyond its boundary, beyond the watershed, in a different region of the cosmic web, a region of dramatically lower density, sitting on the other side of the gravitational divide from the Great Attractor. And its influence crosses that boundary. It reaches across the divide into our supercluster, and it shapes the motion of our galaxy. We are inside Laniakea, but we are being pushed by something outside it, something beyond its boundaries, something in the emptiness that lies beyond the structure we call home. This is the complete picture. We are nested in a supercluster, which is itself nested in the cosmic web, which is itself moving through a universe of almost inconceivable size. And within that picture, we are caught between an attractor inside our supercluster and a repeller outside it, between the heart of our cosmic home and the emptiness beyond its walls. Immeasurable heaven, indeed. Laniakea was named by people who knew what it was, and what it is staggering. It is the largest structure we can call home. It is the ocean in which we swim. And like all oceans, it has boundaries, beyond which the water belongs to a different sea, beyond which the currents flow in a different direction. And in the ocean beyond our boundary, where the currents flow away from us rather than toward us, where matter is sparse and the cosmic web is thin, there sits the Dipole Repeller, quiet, empty, pushing. We are not alone in the river. This is something I want to dwell on for a moment, because it changes the feeling of the journey. The Milky Way is not a solitary traveler, swept along by forces it cannot resist. It is part of a fleet, a vast, loosely bound collection of galaxies, all flowing in roughly the same direction, all responding to the same gravitational landscape, all moving away from the Dipole Repeller and toward the Great Attractor together. The local group, our immediate family of galaxies, contains more than 50 members. The largest are the Milky Way and Andromeda. The rest are smaller, many of them dwarf galaxies, satellites orbiting the two giants. They are all moving together. The local group is flowing as a unit, a small fleet of galaxies navigating the same cosmic river. But beyond the local group, the fleet is larger. The Laniakea Supercluster contains tens of thousands of galaxies, and many of them share this bulk flow, this directed motion away from the void and toward the attractor. The Virgo cluster, one of the nearest large clusters to our local group, some 65 million light years away, is part of this flow. The Centaurus cluster, the heart of the Great Attractor region, is the destination toward which the flow converges. And between us and that destination, hundreds of thousands of galaxies are making the same journey. Think about what that means. You are not the only one moving. The entire visible neighborhood is moving. Millions of stars, billions of planets, incomprehensible quantities of gas and dust and dark matter, all flowing in the same direction, all caught in the same current, all being pushed by the same void and pulled by the same attractor. In human terms, this is like discovering that you are not lost. You thought you were alone in the river, swept away by forces you couldn't understand. But when you look around, you see that everyone else is moving in the same direction. The entire town is on the river with you. The entire city, everyone, for as far as you can see, is flowing the same way. There is something both reassuring and eerie about this. Reassuring because we are not isolated. We are part of something larger, part of a collective motion that encompasses everything we can see and much that we cannot. The galaxy next to ours is making the same journey. The galaxy next to that one is too. We are embedded in a community of motion, a vast coherent flow that links us to structures hundreds of millions of light years away. Eerie, because the scale of the shared motion reveals just how large the forces are that are shaping it. If one galaxy were moving in this direction, we might ascribe it to local conditions. If one cluster were moving this way, we might find a local explanation. But when tens of thousands of galaxies across 500 million light-years of space are all moving in the same direction, toward the same attractor and away from the same repeller, then we are in the presence of something truly immense. The forces that can coordinate the motion of a supercluster are forces of a different order entirely. The galaxies that share our flow have been flowing for billions of years. Some of them began their journey before the solar system formed. Some of them will be further along the path when the sun finally exhausts its fuel and expands into a red giant. The journey is long, far longer than any individual star or planet or civilization can participate in consciously. But the journey is real and it is shared, and that sharing across a supercluster of 100,000 galaxies is one of the most extraordinary facts I know. There is something else worth considering. The galaxies ahead of us in the flow, the ones closer to the Great Attractor, are further along the journey. They have been flowing toward the attractor for just as long as we have, but they started closer to it. And the galaxies behind us, the ones closer to the Dipole Repeller, are further from the attractor. They experience a stronger push from the void and a weaker pull from the attractor. Their motion is slightly different from ours. The gravitational landscape is different at their location. In this sense, the river is not uniform. It is not a single speed, single character flow. It is a complex, three-dimensional field of motion, with each galaxy experiencing a slightly different balance of forces depending on its precise location within the gravitational landscape. The river has eddies and variations. It has regions where the current is faster and regions where it is slower. And mapping all of this, in all its complexity, is the work that Hoffman and his team undertook. The work that revealed the Dipole Repeller as a distinct and measurable feature of the cosmic flow. But through all that complexity, one broad pattern dominates. The flow away from the void, the flow toward the attractor. The pattern that is shared in broad strokes by all the galaxies in our cosmic neighborhood. We are not alone in the river, and we are not the first to have been carried by it. The galaxies that fled before us, that have been flowing for longer, that are further along the path, they are our companions in this journey, separated from us by distances that no human spacecraft will ever cross, moving at speeds that no human instrument will ever match, but flowing in the same direction, pushed by the same nothing, drawn by the same everything. In the deepest sense of the word, they are traveling with us. We have talked about the Dipole Repeller as a force, as a gravitational feature, as the empty pole of our cosmic dipole. But I want to try now to look inside it, not with a telescope, because what is inside it is precisely what makes it difficult to observe, but with imagination, with a slow and careful attempt to picture what it would be like to be there. The Dipole Repeller is not perfectly empty. No region of the universe is perfectly empty. Even the most barren cosmic voids contain some matter, some gas, some dark matter, perhaps a handful of galaxies, faint and scattered, isolated from the crowded structures that define most of the universe. The Dipole Repeller is no exception. Within its boundaries, there are likely some galaxies, though far fewer than the cosmic average would predict. But the density is dramatically, strikingly low, where the average region of the universe might contain a certain number of galaxies per unit volume. The Dipole Repeller region contains far fewer. The matter is thin. The galaxies are sparse. The cosmic web has not woven its threads there with the same density as elsewhere. The filaments are faint. The clusters are absent. The structure, such as it is ghostly and attenuated. If you could somehow travel to the heart of the Dipole Repeller and look around, what would you see? You would still see stars. Whatever galaxies exist within the void would have their own stellar populations, their own swirling disks of suns. But when you turned your telescope outward, when you tried to find the neighbors that everywhere else in the universe are relatively easy to find, you would find very little. The nearest large cluster of galaxies might be hundreds of millions of light years away. The cosmic web, visible from Earth as a rich tracery of filaments and walls and clusters, would be reduced to a few faint threads at the horizon of your vision. The sky would feel different, not in the local sense, not in the sense of stars and planets, but in the sense of deep sky objects, in the sense of other galaxies visible to telescopes. There would be fewer, far fewer. The universe, from inside the Dipole Repeller, would feel emptier than the universe we know, more barren, more vast. The distances between galaxies would feel more absolute, and the night sky, for any hypothetical civilization living in a void galaxy within the Dipole Repeller, would be profoundly different from ours. We on Earth can see the Andromeda Galaxy with the naked eye on a clear night. It is a faint smudge, yes, barely visible, but it is there. It is 2.5 million light years away, and we can see it without instruments. For a civilization inside the Dipole Repeller, the nearest large galaxy might be so much farther that even powerful telescopes would find it dim. The sense of cosmic community, of being surrounded by other galaxies, of living in a populated universe, might simply not arise. They might look out and see, mostly, nothing. What would that do to a civilization? What would it do to their science, their philosophy, their mythology? We know that the discovery of other galaxies, the realization that we were not alone in the universe, was one of the most profound shifts in human understanding. It happened in the 1920s when Edwin Hubble showed that the Andromeda Nebula was not a cloud of gas within our galaxy, but a separate galaxy in its own right. The universe grew, in an instant, by billions of galaxies. The sense of cosmic community expanded overnight. For a civilization inside the Dipole Repeller, that discovery might be far harder to make, or might never be made at all. They might measure the universe and conclude that it is, for all practical purposes, empty, that they are alone, that their galaxy is the only significant structure in existence. This thought experiment is not just a curiosity. It is a reminder of how profoundly our sense of the universe is shaped by our location within it. We know what we know because of where we are. We are in a rich region of the cosmic web, surrounded by galaxies, embedded in a supercluster, flowing through a universe that is dense with structure. And so we have been able to discover that structure, to map it, to understand it. Had we been born inside the Dipole Repeller, we might know almost none of this. The emptiness around us would have hidden the true nature of the cosmos. We would have been, intellectually and scientifically, isolated. What lies inside the void is not nothing, but it is close enough to nothing to make the difference between understanding the universe and never understanding it at all. Close enough to nothing to make a civilization doubt its place in the cosmos, and perhaps conclude, incorrectly, that it had no cosmic context at all. In its emptiness, the Dipole Repeller is not just a gravitational feature. It is a potential prison of ignorance. A place where the truth about the universe might be hidden behind the simple fact of absence. We are fortunate not to live there, and in our fortune, we have a responsibility to look, to measure, to map, to understand, as fully as we can, the structure of the universe we inhabit. Because our location in the river, our place in the cosmic web, will not always provide us with the view we need. The universe is changing. The cosmic web is evolving. And one day, perhaps, even our rich neighborhood will become quieter. Even our view of the cosmic community will narrow. But for now, we can see, we can measure, we can understand, to the degree that we can understand. And part of what we can understand is this. There is a vast, almost empty region of space, 600 million light years away, where the universe is so thin that it pushes us by its very absence. And inside that region, faint and lonely and perhaps forever ignorant of the larger cosmic story, there are galaxies, drifting, in the silence, in the almost nothing. I have been talking about galaxies, about clusters, about voids, about the flowing rivers of cosmic motion, but I have not yet said enough about the thing that underlies all of it, the invisible architecture, the scaffolding that holds the cosmic web in place, that determines where galaxies form and where they do not, that shapes the Dipole Repeller and the Great Attractor alike. I am talking about dark matter and dark energy, the two great invisibles. Together, they make up roughly 95% of the universe. Everything we can see, every star, every galaxy, every nebula, every planet, every atom of ordinary matter in the observable universe, accounts for only about 5% of what exists. The remaining 95% is divided between dark matter, roughly 27%, and dark energy, roughly 68%. Both of them invisible, both of them undetectable by any direct means, both of them known only through their effects. Dark matter is, in many ways, the more intuitive of the two. It is matter. It has mass. It responds to gravity. It clumps. It forms structures. It creates the scaffolding around which ordinary matter, galaxies and gas and dust, accumulates. Dark matter filaments define the cosmic web. Dark matter halos surround every galaxy. The Laniakea Supercluster, the Great Attractor, the filaments and walls of the cosmic web. All of these are, at their core, features of the dark matter distribution. We know dark matter exists because we can see its gravitational effects. Galaxies spin faster than the visible matter within them can account for. The extra gravitational pull must come from dark matter halos. Light from distant galaxies bends as it passes through galaxy clusters. The bending is too strong to be explained by the visible matter alone. The pattern of fluctuations in the cosmic microwave background matches predictions that assume dark matter is present. Everywhere we look, the evidence is overwhelming. Dark matter is real. It is present, and it is the dominant form of matter in the universe. But we do not know what it is. We do not know what particles it consists of. We have never directly detected a dark matter particle in any laboratory experiment. We know it is there, and we know roughly how much of it there is, and we know how it is distributed. But its fundamental nature remains one of the deepest mysteries in physics. The Dipole Repeller, in this light, is partly a feature of the dark matter distribution. The region of space it occupies is underdense not just in ordinary matter, not just in galaxies, but in dark matter as well. The invisible scaffolding is thin there. The filaments of the cosmic web have not woven themselves densely through that region. And because the scaffolding is thin, ordinary matter has not accumulated. Galaxies have not formed in large numbers. The void is empty in both its visible and its invisible components. And this underdensity of dark matter is itself a fossil, a record of conditions in the very early universe, when the initial distribution of matter was set by quantum fluctuations in the moments after the Big Bang, then stretched to cosmic scales by inflation. The dark matter is thin in the Dipole Repeller region because the primordial fluctuations happened to produce an underdensity there. And billions of years of gravitational evolution have amplified that underdensity, making it more pronounced, more extreme, as matter flows out into the surrounding cosmic web. The dipole repeller is, in a profound sense, a message from the beginning of time, written in the language of dark matter. In a region of space where the cosmic web failed to properly knit itself together, dark energy is harder to intuit. It is not matter. It does not clump. It does not form structures. It is, as far as we can tell, uniformly distributed throughout space, a property of space itself. And its effect is to accelerate the expansion of the universe, not to slow it down as gravity does, but to speed it up. In dense regions, in clusters and filaments, gravity partially counters this expansion. The matter holds together. The structures persist. But in voids, where matter is sparse and gravity is weak, dark energy acts almost unopposed. It stretches space. It expands the void from within. It makes the emptiness larger and emptier over time. This means that the dipole repeller is not static. It is growing. As dark energy stretches the space within it, as matter continues to flow out into the surrounding cosmic web, the void deepens. Its underdensity becomes more pronounced. Its repelling influence, the influence of the absence, becomes stronger. In the far future, billions of years from now, the dipole repeller will be an even more extreme feature of the cosmic landscape than it is today, and we will be even further away from it, pushed along our river, moved by the growing nothingness at our backs. There is something almost sublime about the invisible architecture, dark matter and dark energy, the two great unknowns, shaping everything we can see, creating the structures in which galaxies live, creating the voids from which galaxies flee, writing the gravitational landscape that determines the path of every galaxy in the observable universe. And we, sitting in our small galaxy on the edge of a supercluster, can see none of it directly. We can only infer it. We can only read the motions of galaxies the way an ancient sailor read the currents of the sea, knowing that something was beneath the surface, knowing that the water moved for a reason, but unable to reach down and touch the thing that was doing the moving. The invisible architecture is the deepest truth of our cosmic situation, and the dipole repeller is one of its most dramatic expressions, a vast underdensity of both visible and invisible matter, sitting behind us in the cosmic river, pushing us forward with the force of its absence, growing more extreme with every passing billion years. We cannot see it. We can only know it. And there is a difference between those two things that the universe, in its particular way, keeps reminding us of. I want to take you somewhere, just for a moment. Not physically, not even quite in imagination, but in the slow, gentle way that a story can take you somewhere, a place just beyond the edge of what we know. Imagine you could stand at the boundary of the dipole repeller, not inside it, not in the thin, ghostly interior where galaxies are sparse and the cosmic web is barely visible, but at the edge, at the place where the void meets the surrounding structure, where the emptiness gives way to the beginning of the cosmic web. What would that edge look like? It would not be sharp. There is no wall, no clear boundary, no line you could stand on and say, here is where the void ends and the structure begins. The transition is gradual, and the way it appears to an observer depends on the scale at which you look. On very large scales, on the scale of hundreds of millions of light years, the boundary is clear in the statistics. Galaxy density drops sharply as you move into the void. But on smaller scales, the boundary is blurry, a gradual thinning, a slow fading, like the edge of a fog bank seen from inside. But let us say you could stand somewhere at the approximate boundary, and let us say you could look in two directions. Looking inward, into the void, you would see a sky that is darker than the sky we know, not in the local sense, not in the sense of stars and planets, but in the deep sky sense. You would see fewer galaxies, much fewer, the background of faint smudges that fills a deep exposure photograph taken from Earth. the hundreds of galaxies visible in every small patch of sky. That background would be thinner, dimmer, more sparse. In some directions, you might see almost nothing at distant scales. The void would stretch away from you, vast and hushed, for hundreds of millions of light years. Looking outward, toward the surrounding cosmic web, the sky would brighten. Not instantly, not dramatically, but over time, as your eyes adjusted, you would begin to see structure. Faint filaments of galaxies threading across the sky, the suggestion of walls and clusters, denser regions where the cosmic web had done its work. The universe as we know it, from our location in Laniakea, visible in that direction as a richness, a texture, a presence. The contrast would be haunting. Behind you, the void, the almost nothing, the silence of 600 million light years of emptiness. Ahead of you, the web, the structure, the presence, the river of galaxies flowing away from the void and into the richer regions of the cosmic landscape. And if you could measure the motion of the galaxies around you, you would see something remarkable. On the void side, galaxies moving away, flowing outward from the underdensity, following the current of the gravitational river. On the web side, galaxies also moving, but in the other direction, flowing toward the attractor, drawn inward. And at the boundary where you stand, you would be at the place where both flows originate. The divide, the watershed, the place where the river decides which way to run. It is, in its way, one of the most dramatic locations in the observable universe. Not because anything dramatic happens there, not because there is an explosion or a collision or a spectacular event, but because it is the meeting point of two of the most powerful gravitational influences in our cosmic neighborhood. The edge of the nothingness that pushes, the edge of the everything that pulls. And it is 600 million light years away from you. 600 million light years at the speed of light, at the speed of Voyager 1, the fastest human-made object ever launched. It would take roughly 11 billion years to travel 1 light year. The distance to the edge of the Dipole Repeller, in those terms, is so far beyond any human scale of travel that it is effectively infinite. We will never stand at that boundary. No human being will. No human civilization, no matter how advanced it might become, is likely to travel anywhere near that distance in any time frame that has meaning. We know the edge is there. We have mapped it in broad strokes from 600 million light years away, using the motions of galaxies as our guide. We have inferred its location, its approximate shape, its character. We have given it a name, but we will never stand there. We will never look inward at the void from its edge. We will never feel the contrast between the emptiness and the structure. We will never experience the haunting view of the nothing and the something side by side across a boundary that extends for hundreds of millions of light years. There is something in this that I find both humbling and strangely freeing. The universe contains wonders that we will never see, places we will never go, views we will never have. We can know about them. We can describe them. We can imagine them, as we are doing now, but we will never experience them directly. And yet the universe does not withhold its influence. The Dipole Repeller does not require us to visit it in order to push us. The Great Attractor does not require us to understand it in order to pull us. The forces act, the river flows, the galaxies move, whether we know about it or not, whether we have mapped it or not, whether we are awake or asleep. We are moved by things we will never see. We are shaped by forces we will never touch. We are part of a story that extends far beyond the horizon of our experience. And there is something in that thought that is less frightening than it first appears. Because if we are moved by things we cannot see, then the universe is richer than our perception. It contains more than our instruments reveal. It holds forces and structures and wonders that exist independently of our awareness of them. The universe is not dependent on us. It is not organized around our perception. It does not wait for us to understand it before it acts. It simply is, vast and patient and indifferent, pushing, pulling, flowing, in the dark. And we, for all our smallness, have found a way to catch a glimpse of it, to stand, metaphorically, at the edge of a void 600 million light years away and look inward at the almost nothing and know what we are seeing. That, too, is extraordinary. There is a revolution in human thought that began 5 centuries ago and has never really stopped. We call it the Copernican Revolution, after Nicholas Copernicus, the Polish astronomer who published, in 1543, his argument that the Earth was not the center of the solar system, that the Sun, not the Earth, sat at the center, that we were moving around it, not the other way. It was a shattering idea. For thousands of years, humanity had placed itself at the center of the universe, not out of arrogance exactly, but out of the simple, intuitive feeling that where you are is the center of what you see. You stand on the earth and look out, and everything seems to revolve around you. The sun rises and sets. The moon circles overhead. The stars will above you. The whole sky seems to organize itself around the point where you stand. Copernicus said no. You are not the center. You are moving. And in moving, you create the illusion of being at the center. In the centuries since Copernicus, this lesson has been repeated, and each repetition has moved us further from the center, not just of the solar system, of the galaxy, of the universe. At every scale we have examined, we have found that we are not at the center. We are not in a special place. We are not at a special location. The Milky Way is not at the center of the local group. Andromeda is the dominant member. The local group is not at the center of Laniakea. We are near its outer edge. Laniakea is not at the center of the observable universe. It is one of countless superclusters distributed across the cosmic web. And the observable universe is not, as far as we can tell, the center of anything. It is simply the part of the universe that light has had time to reach us from, in the roughly 13.8 billion years since the Big Bang. We are not the center of anything. At every scale, we are peripheral, eccentric, off to one side. And the story of the Dipole Repeller adds another layer to this. We are not just off to one side, spatially. We are in motion, directed, sustained, billion-year motion, away from one structure and toward another. The direction of our motion was not chosen. The speed of our motion was not chosen. The destination of our motion was not chosen. We were placed by circumstance, by the initial conditions of the early universe, by the distribution of dark matter in our cosmic neighborhood, in a particular location in the gravitational river. And the river has been carrying us ever since. There is no center to this river. There is no starting point we can call our origin. There is only the current, the push of the void, the pull of the attractor, the flow of the fleet of galaxies we travel with. And there is our small position within that flow, not leading, not following, not at the center or the edge, just there, moving, as everything moves, in the directions the landscape demands. This decentering, this repeated removal of humanity from any special position in the cosmos, is one of the most psychologically challenging aspects of the scientific view of the universe. We are wired to feel central. We experience the world from a first-person perspective. Everything radiates outward from the point where we stand. The horizon is equidistant in every direction. The sky is above us. The ground is below. We are, experientially, at the center of our own perceptual world. And then science comes and says, gently but firmly, you are not at the center, not of the solar system, not of the galaxy, not of the universe, not of the cosmic flow. You are a passenger in a small ship in a vast river, flowing between a void and an attractor, on the edge of a supercluster, in one of billions of galaxies. in one of the cosmic web's countless knots and filaments, in an observable universe that is itself only a small fraction of what exists. For some people, this is devastating. It feels like a loss, a diminishment. The universe does not care about us. We are not special. We are not central. We are not even particularly significant by the measures the universe uses. But I want to suggest a different way to hold this. Not as a loss, but as a gift. The universe is not organized around us, and that means it is vastly larger than us. It contains wonders we did not put there, structures we did not build, forces we did not create, and we have been given, through the extraordinary capacity of the human mind, the ability to discover those wonders, to map those structures, to name those forces. We are not the center of anything. And because we are not the center, the universe is full of things that have nothing to do with us, full of things that existed before us and will exist after us, full of things that are simply there, doing their vast and silent work, regardless of our attention or our comprehension. The Dipole Repeller was pushing our galaxy long before any human being existed to notice. It will continue pushing long after the last human being is gone. Its existence is independent of our knowledge of it. Its power is not derived from our attention, and we discovered it anyway. We, these small creatures on a small planet orbiting a small star on the edge of a middling galaxy. We discovered a void 600 million light years away that has been shaping our path through the cosmos for billions of years. We found it by measuring the motions of thousands of galaxies. We named it. We understood it. That is not the act of something insignificant. That is not the accomplishment of something peripheral. That is one of the most astonishing things that has ever happened in the 400 million years of animal life on Earth. A creature made of atoms, using instruments made of atoms, looking out at a universe made of atoms, and finding the invisible forces that shape its largest structures. We are not the center of anything, but we are, as far as we know, the only thing in the universe that knows this. Let us do some arithmetic together. Slow arithmetic, quiet arithmetic, the kind that does not require a pencil, only attention, and a willingness to let numbers carry you somewhere unexpected. Our local group of galaxies is moving at roughly 630 kilometers per second. That is the peculiar velocity. The velocity relative to the cosmic microwave background. The velocity that represents the net effect of the Dipole Repeller pushing and the Great Attractor pulling. 630 kilometers per second. 2,268,000 kilometers per hour. Now, how long has the universe existed? Approximately 13.8 billion years. But the cosmic flows we are talking about, the bulk motion of galaxies within the large-scale structure, has been building for most of that time. Let us say, conservatively, that our local group has been participating in this particular bulk flow for something on the order of 10 billion years. 10 billion years. At 630 kilometers per second. The total distance covered, at that rate, over that time, is approximately 200 million light years. Give or take, given that the rate was not constant, given that the gravitational landscape has changed over time, but something on the order of hundreds of millions of light years. That is the distance we have traveled in the river, in the cosmic flow, being pushed by the void and pulled by the attractor. Hundreds of millions of light years. A distance so vast that it makes the Milky Way, at 100,000 light years across, seem almost microscopically small. And we are still moving. We have not arrived anywhere. The Great Attractor, for all its gravitational power, is not something we will reach in any time frame that has human meaning. It is hundreds of millions of light years away. At our current speed, it would take hundreds of billions of years to close that distance, assuming the universe were not expanding and the landscape were not changing. In practice, The expansion of the universe ensures that the distances involved change over time in complex ways. But the point is clear. We are not arriving. We are not close. We are in the middle of a journey so long that no civilization could survive to see its end. We know where we are going. Broadly, roughly, we know that we are flowing toward the Great Attractor, toward the heart of Laniakea, in the direction of the Centaurus cluster. We know that the Dipole Repeller is behind us, and that it is pushing us. We know the direction. We know the speed, but we do not know what we will find when we get there. If by some impossible magic any of us could be transported to where the Milky Way will be in 1 billion years, we would find ourselves in a universe that looks different from the one we know. The cosmic web would have evolved. The flows would have changed. The Dipole Repeller behind us would be even emptier than it is today. The Great Attractor region ahead of us would be even denser. And there is the chilling part. Not that we are moving, not that we are being pushed by a void, not even that the journey will take longer than any civilization can survive. The chilling part is the question it raises about what is behind us. We are moving away from the Dipole Repeller. We have been moving away from it for billions of years. And in all that time, no signal, no information, no light could have traveled from the deepest interior of that void to us, turned around, and come back. The universe is large, and it is old, but it is not so large and old that we have had time to fully probe what lies in the depths of the Dipole Repeller. We know it is a void. We know it is large. We know it is underdense. We know its approximate location and extent, but we do not know everything that is in it. We cannot resolve all of its contents. We cannot see every faint galaxy, every wisp of gas, every dark matter filament that might thread through its interior. We see its broad outline, its rough shape, its general character. The details are hidden by distance, hidden by the faintness of the objects within it, hidden by the limits of our instruments, hidden by the simple fact that 600 million light years is a long way, and the universe is under no obligation to make itself legible to us. What we know from arithmetic, from the careful tallying of galactic velocities, from the mathematical reconstruction of a flow field. The Dipole Repeller was found not by seeing it, but by calculating that it must exist, by reading the downstream current and inferring the upstream source. The chilling arithmetic is not just the numbers about our speed and our distance traveled. It is the arithmetic of inference, the knowledge that what we know about the thing pushing us, we know only indirectly. We have never seen it properly. We have only felt its effects. And what lies in its depths, what details hide in the emptiness 600 million light years behind us, remains, for now, unknown. The arithmetic tells us we are moving at 2 million kilometers per hour. It tells us we have been doing so for billions of years. It tells us we are heading toward the Great Attractor and away from the Dipole Repeller. All of this is known. All of this is calculated. All of this is written in the data. But the arithmetic cannot tell us everything. It cannot illuminate the interior of the void in detail. It cannot resolve the faint structures within it. It cannot tell us whether there are surprises there that we have not yet imagined. It can only say what it says. There is something behind us. It is pushing us. It is very large, and it is mostly empty. Mostly. There is a question I have been holding back, saving for this moment, when the night is deep enough and the mind quiet enough to sit with it properly. We know the Dipole Repeller is pushing us. We know it is vast and mostly empty. We know it is 600 million light years away. We know it is growing emptier over time as dark energy stretches its interior and matter flows out of it into the surrounding cosmic web. But what we don't know is, in many ways, more interesting than what we do. The Dipole Repeller region was identified through a reconstruction of the local velocity field. That reconstruction is based on galaxy surveys, on catalogs of galaxy positions and velocities, on mathematical techniques that infer the distribution of matter from the distribution of motion. It is an impressive achievement, one of the most ambitious reconstructions of the gravitational landscape ever attempted. But it has limits. Surveys have horizons. Telescopes have sensitivity limits. The faintest galaxies, the most diffuse structures, the subtlest features of the cosmic web can slip below the threshold of detectability. What we have mapped is the broad outline of the dipole repeller, the gross features, the dominant character. The details remain largely unresolved. And the details, in cosmology as in life, are where the surprises hide. Is the dipole repeller a single coherent void, or is it a complex of several overlapping underdensities? Are there filaments of galaxies threading through its interior that are too faint for current surveys to detect? Is the underdensity deeper at its core than at its edges? And if so, how deep? These are questions that current data can only partially answer. More fundamentally, we cannot see through the dipole repeller to what lies beyond it. The observable universe has a horizon, defined by the distance light has traveled since the Big Bang. The dipole repeller, at 600 million light-years, is well within our observable universe. But what lies on the far side of it? What structures exist beyond the void in the direction away from us? We know only in the broad statistical sense. The cosmic web is roughly similar in all directions, on the largest scales, but the specific features, the specific clusters and voids and filaments on the far side of the dipole repeller from us, we have not mapped in detail. And beyond the observable universe entirely, beyond the horizon of our perception, there is everything we cannot see and may never see. The dipole repeller is one feature in a cosmic landscape that may extend far beyond what we can observe. Our bulk flow may be influenced by structures even more distant than the dipole repeller itself. There are hints in the data of what some cosmologists call dark flow, a large-scale motion of galaxies that might point to influences from beyond our observable horizon. This is a deeply controversial idea. It is contested, it is uncertain, but it points to the possibility that even our most complete maps of the local cosmic structure are only partial, only an approximation of a larger truth we cannot yet access. What else is pushing us? What else is pulling us? What lies beyond the dipole repeller, in the regions of the universe that our telescopes cannot reach, that our surveys have not mapped, that our models have not incorporated? We do not know. We cannot know. Not yet. Perhaps not ever. The void does not tell us. It sits there 600 million light-years away, pushing with the force of its absence, and it does not speak. It does not explain itself. It does not reveal its interior. It does not illuminate what lies beyond it. It simply pushes, in silence, in darkness, in the particular, haunting language of nothingness. And we listen, we measure, we infer, we reconstruct the flow field and find its outlines in the data. We name it, we write papers about it, we build models of it. We talk about it in the quiet hours of the night, as the universe continues its ancient work around us. But we do not fully know it. We cannot. The void keeps its secrets. The emptiness is not transparent. The silence does not explain itself. And this, I think, is the deepest truth about the dipole repeller. Not its size, not its power, not its role in our cosmic motion, but its fundamental inscrutability, the way it holds its mysteries, the way the darkness behind us refuses to fully reveal itself, the way the thing that is pushing us remains, at its heart, unknown. We are moving through a universe we do not fully understand. We are being pushed by a void we cannot fully see. We are flowing through a cosmic river whose full length and depth and character we have not yet mapped. And the night is dark, and the sky is vast, and the void is behind us, doing its silent work. We know where we are going. But what is truly behind us, in that great emptiness, remains the ultimate mystery. I have been building, over the course of this night, towards something that might seem unlikely. I have been talking about a vast nothingness pushing our galaxy through the cosmos, about invisible forces shaping our path, about a universe that does not care about us, does not notice us, does not organize itself around us, about the limits of our knowledge, the inscrutability of the void, the mysteries that remain after all the mathematics is done. These are not comfortable things at first glance. They sound like reasons for unease, for the particular kind of unease that comes from realizing how small you are in a cosmos this large. But I have been holding something else alongside them, something quieter, something that only becomes audible when the louder themes have been stated. There is a strange comfort in being pushed. Think about what it means to be pushed, not in the violent sense, not in the sense of being shoved or displaced against your will, but in the sense of a river carrying you, in the sense of a wind at your back, in the sense of a force that has been present since before you were born, shaping your path, moving you through a landscape so vast that you could never navigate it yourself. We did not choose to be in this river. We did not choose to be pushed by the dipole repeller. We did not choose the direction of our motion, or the speed, or the destination. These things were determined by forces that operated billions of years before any human being existed. The initial conditions of the early universe, the distribution of dark matter, the outcome of quantum fluctuations in the first moments after the Big Bang. All of this happened, and the result was a river, and we were placed in it, and it has been carrying us ever since. And we are fine. I mean that in a simple and literal sense. We are fine. The journey has not harmed us. The push of the void has not disrupted our planet, has not disturbed our star, has not interfered with the slow evolution of life on Earth. The forces are real, and they are immense, and they are completely imperceptible to any living thing. They happen at a scale that life cannot notice, at a speed that evolution cannot detect, at a frequency that human civilization cannot measure. We are fine. The void is pushing us, and it does not matter in the most immediate and practical sense. It does not change what we will have for breakfast tomorrow. It does not affect the people we love. It does not alter the texture of the day, the quality of the light, the sound of the world around us. And yet knowing about it changes something, not in the world, in us. To know that you are part of something this large is not diminishing, or it does not have to be. It can be, instead, a source of a very particular kind of peace. The peace that comes from recognizing that you are embedded in a process that is ancient and vast and ongoing, that your small life is happening within a cosmic story of extraordinary scale, that the same universe that produced the dipole repeller produced you, that the forces that push galaxies through the cosmic web also compressed the molecular clouds that became the sun, also warmed the early Earth, also drove the chemistry that eventually, improbably, produced thinking beings who could look up at the night sky and wonder about what they saw. You are not separate from the river. You are in it, made of it. The atoms in your body were forged in stars. The stars were born in galaxies. The galaxies were shaped by the same dark matter distribution that created the dipole repeller. Everything is connected. Everything is part of the same story. The void and you are made of the same universe. The comfort of being pushed is the comfort of belonging. You belong to a cosmos that is pushing you. You are part of something that began at the Big Bang and has been unfolding ever since. You are not an observer of the universe. You are a participant in it, as much a participant as the galaxies themselves, as much a product of the cosmic flow as the Milky Way. There is also the comfort of scale. When you hold in your mind the scale of the dipole repeller, the scale of Laniakea, the scale of our motion through the cosmos, the scale of your daily concerns shifts, not disappears, not becomes meaningless. but shifts. The river is so vast. The journey is so long. The forces at play are so immense. And within all of that, you are here, breathing, resting, warm, alive. That is not insignificance. That is a miracle of proportion. The universe is mostly empty, mostly dark, mostly silent. And yet here, on this small planet, warmed by this small star, in this small corner of a middling galaxy on the edge of an enormous supercluster, there is life. There is consciousness. There are beings who can look at the sky and measure the motion of galaxies and find the void that pushes them and give it a name. The Dipole Repeller has been pushing our galaxy for billions of years. It has never paused. It has never relented. It has never noticed us. And we have just, in the last few years, noticed it. That noticing is everything. That noticing is what makes us what we are. The universe does not know that we exist, but we know that it does. And in that asymmetry, in that one-sided awareness, there is something that feels, to me, like a kind of grace. We are small. We are pushed. We are temporary. And we are aware. And that awareness of the void, of the attractor, of the river, of the scale, of the silence, is perhaps the most extraordinary thing in the universe. Or at least, the most extraordinary thing we know of. The strange comfort of being pushed is the comfort of awareness. The comfort of knowing, of having looked at the sky and not simply accepted its beauty, but asked what it means. Of having built instruments and run calculations and reconstructed the flow of galaxies and found the name for the nothing that pushes us. We are pushed. We are small. And we know it is late now or early or whatever time it is in the place where you are resting. The room around you has settled. Your breathing has slowed. The world outside is quiet. Or perhaps it has its own kind of sound. The sound of a city at night, or rain on windows, or wind moving through trees. And behind all of that, behind the room and the house and the city and the country and the planet, the river is flowing. It has been flowing tonight as we talked. It will flow tomorrow as you go about your day. It will flow in a year, and in 1,000 years, and in 1,000,000 years. The void behind us will continue its silent push. The great attractor ahead of us will continue its patient pull. The fleet of galaxies around us will continue their shared journey. All of it, moving in that grand and imperceptible current at 2 million kilometers per hour. You cannot feel it. You have never felt it. You will never feel it. It is too large, too slow, on the scale of a human life. Too vast to register in any nerve or muscle or sense organ. The river carries you without touching you. The void pushes you without reaching you. And that is all right. That is how it is supposed to be. You do not need to feel the river to be carried by it. You do not need to know the name of the void to be pushed by it. The universe does its work regardless. The forces act. The galaxies flow. The journey continues. You can let go of it now. Not permanently, not forever. You can pick it up again tomorrow. This vast and haunting story, this river between nothing and everything. But for now, for these last quiet minutes before sleep claims you, you can let it rest. Let the numbers fade. Let the distances dissolve. Let the void become simply a word again, rather than a concept, rather than a force, rather than something 600 million light years away and growing emptier by the billion year. Just rest. The Milky Way is moving. You are moving. The atoms in your body are moving, vibrating, spinning, doing the quantum mechanical work that keeps matter coherent. And beneath all of that motion, at every scale from the subatomic to the cosmic, there is something that feels like stillness. Not true stillness, not the absence of motion, but something that rests beneath motion, something that motion cannot disturb. That is where you are going now, into that stillness beneath the motion, that quiet beneath the current. The void pushes, the attractor pulls, the river flows. And you sleep. You sleep in a galaxy that is moving at 2 million kilometers per hour. You sleep while the cosmic web continues its ancient evolution. You sleep while dark matter halos spin silently around galaxies, and dark energy stretches the space inside voids, and the large-scale structure of the universe slowly, irresistibly deepens. You sleep while all of this happens, and all of this happens while you sleep. The Dipole Repeller will be there when you wake, still pushing, still empty, still 600 million light years away. And you will be here, warm and rested and small and aware, in your small corner of the river, in your small place in the fleet, in your small position in the grandest current any of us has ever known. Good night. Drift now, into the current. Let the void push you. Let the attractor draw you. Let the river carry you, as it has always carried you, as it will always carry you. You are in the river. You are safe. You are moving. And somewhere, 600 million light years behind you, in the great and haunting silence of the Dipole Repeller, the nothingness does its patient work, pushing, in the dark, in the quiet, in the vast and ancient and beautiful emptiness. Sleep now. The universe has you.